So my name is Jeff and I'm with Subsurface Solutions. So welcome and thank you all for being here. So what we're going to do today is I'm going to do the basics of underground utility locating. What I've drawn for you up here on the board is a simple locate. We have your ground rod, we have your transmitter, which is going to be this piece of equipment here in front of you for this presentation. You all have something similar to that, I'm sure. Then we have our target line, whatever we're going to try to locate. Now, when looking at this, we also have our black lead, our negative off to our ground rod, and we have our red lead off to our target line. What is the most important component when setting up our locates? Ground. Yes. It's always your ground. Why is that? Well, when you turn your transmitter on, you're turning on a giant switch. Uses the batteries inside to alternate current at the frequency we ask it to inside of 1 second. We're going to talk about frequency selection here later on as well. Giant switch alternating current. So current goes out, travels down our leads, onto our target line, leaves, comes back and finds our ground rod. So when we're locating, we're quite simply setting up a circuit for current to flow on and get a return path back to that ground. All right? That movement has a byproduct, which is electromagnetic fields, and that's what we're ultimately going to find with our locate receiver. So when it comes to grounding, we like to have this out and away, get everything set up properly. We're going to talk about all of that. So ground is number one for us. When it comes to grounding, what do you normally get within your kit? Something like this. Everybody gets something like that when they started, maybe something a little bit shorter. So the first thing, if you're ever taking my class, I always recommend try to upgrade this if you can. More earth contact is going to lead to better results when it comes to your locates. So we'd like for this to even be a little bit longer, maybe a greater diameter. I like to use a 3-foot or 4-foot steel probe rod. Why does everybody sell you something like this though within your kit? Because it fits in the bag, because it's cheaper. It's really about liability. Attorneys run America. If you're not hip to that yet, most of you I'm sure probably are. So we can't give you something that you're going to go out there and maybe hit a street light or a drop or a gas service or something like that with, right? When we look at our grounds, we've got what comes in here, but what do we like to do when we upgrade? Well, what we're attempting to do is this. My current comes back to find that little ground rod. My current comes up closer to the surface. What do I have there just above the surface? Competition, distortion, interference in the form of other radio waves I can then hear in my receiver. So what I'm looking for when I upgrade is keep my current lower and use the soil as a vertical buffer between all those other errand waves and my signal when I'm trying to locate. And the deeper I get, I also get closer to the water table. It is the more conductive soil, get down closer to the clay. What happens? I establish a better circuit there as well. This is how we would upgrade. There are other things we can use. We're going to play some Pictionary. I can't draw very well, but when you think you know what it is, shout it out. Here we go. What's that?
Chain link fence.
Chain link fence. Good. Next.
Stop sign.
Stop sign. 2 points for you. And finally, what's this one? What is that? The horizon?
Culvert.
Anybody see the sun or the moon? The culvert. Exactly right. Almost nobody gets that. So this is a storm sewer culvert with some moisture, some water in the bottom of it. Now, all of these items can be used as alternate grounds when it comes to locating. So if I take my negative lead and I put it on that chain link fence, think about this. All of these metal posts add up to a ton of earth surface contact for me. Now what I can't do with the ground like this, and frankly even these other ones, is I can't go anywhere near that with my receiver. So if I'm going to be doing a single lot locate and I'm in a confined space, I'm not going to use something as large as this fence here. But if I want to get onto that and I know I'm going to be 30 or 40 feet from that fence and now I want to run down the road, I can happily do so because of all this contact, and I couple that with a low frequency and I can get great distance out of it. So you want to be mindful of where this is in respect to where you're going to try to run. When it comes to things like the stop signs are great. You have too much hard surface area, asphalt, concrete, pea gravel. You can't get a ground of your own down and in, so you can look for other things that already exist there, like signs or boot scrapers or steel columns on a ballard outside of a garage door. We'll talk about things like that. Lots and lots of options, usually some corrosion here at the bottom. This can be a great, great ground. Now, if you take my class and you call me one of these days and you say, hey, I'm on that metal sign like you said, and I have to have you shoot a video and I find out you've got a 4x4 wooden post, right? Right? That's an insulator. So we're not going to be able to use that. So please don't use wood as your ground. Now, the storm sewer culvert, with this, we can get onto these. The larger the better. Usually some moisture in the bottom. But with really low frequencies like ELF, which most of you will never use, extra low frequency, it's so low that it's almost DC current instead of AC, that we can push 4 to 5 miles with a storm sewer culvert the size that you and I could walk through. Those are some things that we can use. What do we not want to use? Somebody say it.
Wire.
What?
Ground wire.
Yes, ground wire. And what else? What do we just learn we're not going to use?
Wood.
Thank you, everybody. No wood. What I really want to avoid is something like this. You just said ground wire and you're exactly right. Let's say I've got 3 wooden power poles, all with grounds at the base of them. And I've got something out there on the easement that I'm trying to focus on. Let's say we've got a communications line here. It's probably fiber optic. Has anyone seen any fiber go in the ground lately? Anything like that? Well, it's coming if you haven't. All right? So, what we don't want to see from anyone is this. Set your transmitter up there in the middle, run off your ground, hook up your target line, and what can you possibly have there in the air? Let's say you've got a transformer. You can have straight current come off that transformer, travel down your ground, and then fry your transmitter. It's possible. It happened to one of my guys about 10 years ago in the field, and I've heard about it a couple other times. It's rare, but it does happen. So that's the first problem we have. Now, what's not rare and can happen very easily is current travels up that ground. Now you hit your aerial feeds, go and pull the pole. Let's say something dips down that third one and then joins the easement. What do I have now? I have current both on my target line as well as this facility, and I start to run into issues. Because what you just did by choosing that as your ground was you took the circuit that you were building and trying to establish, and you added that circuit to it. And you got to say this with me. When it comes to this, when we're dealing with current, current is looking for the path of least resistance. So your current views all of this as an option. So what I implore you to do is to not use anything that's part of anything else. Find your own independent ground. Now, when it comes to ground, where would I like to be? You see here in the diagram about 90 degrees. Want my ground rod out and away. Why is that? I really do want my current to proactively leave and go and find that ground rod. I don't want it to view other things as options. What I'm saying is this. If I set my stuff up down here, nice and tight, on top of the easement, and ground myself out, current goes out, where does it want to go back to, everybody? Right back over the top of me. Try and get back to this ground rod as quickly as possible. But what do I have out there on the easement? Well, if I'm trying to locate this communications line, I might have power, gas, abandoned gas, water, fiber, right? So my current will view all of these things that are highly conductive as superhighways to bleed off onto to try to get back to this ground rod as quickly as possible. Now you run into a real issue. So where would I like my ground to be? I'd really like for it to be out here. With our kits, you have 10 feet of red and 10 feet of black. So you got 20 feet of potential. I like to go about 15, 18 feet and get that out away from me. Too many people keep it just too close, but they also think they're only grounding the equipment to protect the equipment or protect themselves. It really is the circuit that you're trying to establish and set up so things can go well. So the placement of this, everyone's always concerned with where your transmitter ends up. It's really about where your ground ends up and how well of a ground you have. So you have, within these kits, you have some options like leads and lead extensions. Oh, these are, there we go. So we have our traditional leads, 10 feet of red, 10 feet of black. We also have lead extensions that come with the kit. They're yellow, and you can also get lead extenders such as this. Why would I want something like that? Well, if I'm in a downtown or municipal setting, I have nothing but hard surface. So I can run myself out, get the soft surface, and deploy a ground and have no problems. What we really want to avoid here is this, and here as well. When you have all your current back and forth there on top of you, now you can start to inadvertently create misshapen electromagnetic fields. So let's say this is a cross-section of your facility. This is what you're trying to locate. Your signal emanates from the center of what you're locating. That's also where your depth is measured from. So for all of you that do tracer wire and things like that, it's a negligible amount, not a big deal. But for actual pipeline locators, your signal is coming from the middle of what you're locating, so you have to subtract half the diameter of your pipe because that's how deep it's going to be. It's never measured to the outside or the top. All right? So you've got current going out and away, just like this. And when everything's going well, you have a perfectly cylindrical electromagnetic field around that facility. But if current's coming back, like this, on something else, I have a second facility, current's coming back, and I have a second electromagnetic field. What do like magnets do? That's right. He's saying retract, they repel, they push apart. And I'm grateful we did not have some kind of great debate on that. I've let that rage on for like 10 minutes before because it interests me. Yes, they're going to push apart. And that's what they're going to do here too. So when we're looking at this, what's actually happening is, as these start to affect one another and push apart, now I can actually get my signals out here on these outer edges instead of top dead center like I wanted to, and there'll be a correlation between approximately how far off this was and how deep this was. Anyone that's done this long enough has had this happen to them. Someone's dug on your facility, and they said, man, you're about 3 foot off today. And if you think about it, you're probably about 3 foot down. That's a product of too much current back and forth here on top of you and it not going and finding your ground rod. All right? So we can create interference just by not setting things up correctly. That's what we want to avoid. Now, the reason we spend so much time on grounding is this is the building block that everything else in locating is predicated on. If we have a great ground, we establish a strong circuit. If we establish a strong circuit, then we have good flow. If we have good flow, we have good electromagnetic fields. Now we have something we can go locate and be effective with. All right? So this is where it all begins for us. Now, we'll move past grounding. We'll get into some of the real nuts and bolts of what's happening with Locator. I'm going to take you back to our simple circuit. You'll notice that every time I draw this, I do like to put the negative or the black lead out to the ground, and I put the red over to my target line. Do that for a reason. There is functionality now that exists in these kits, like current direction, or the use of an A-frame. Anybody in here ever use an A-frame to go out there and find faults, open shorts, things like that? Several of you have. Okay. So that arrow that guides you into the open or short knows the difference between the red and black lead. If you have those flip-flopped, it'll send you the other direction. All right, same thing with current direction. Current direction is a feature that exists in our locator kits now that will tell us that the current is leaving our transmitter and traveling down our target line and comes back to our ground. If you ever get to the point that your arrow points back at you, you're bleeding off onto something else. Your current has found a return to come back toward you, and it should only be going away until it gets to this. So it's kind of like a warning light, letting you know that you can't be following your current any longer. You go back to the last place that it was forward, do a 360 sweep, you find, oh, it took a hard 90 or made a 45 or something like that. All right? So when it comes to locating, we're back to our giant switch, alternating current. Again, that current goes out, you're already familiar with this, travels down our line, comes back and finds our ground. We measure this movement of current out here on our circuit in amperage. In this case, it's milliamps. It's very, very small. So we have amperage. And then out there on the system, we can have different forms of resistance, like too much corrosion, gasket, rubber boot, some kind of dresser. All of these items are resistance to my current flowing freely and getting back to that ground rod. So now I have resistance. And then finally, my third component is going to be voltage. And that voltage is being supplied by the batteries within my locator. So the way this works is this. Your current goes out, leaves your transmitter, comes up against resistance and gets blocked. So amps have stopped flowing. Your voltage, in this case, will automatically adjust between 0 volts and 30 and give you the pushing power needed to move that amperage across the resistance. This could be 1, 5, 10, whatever it needs to help complete the circuit. So voltage goes up, pushes you across again, 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 and then drives this back home to your ground rod. So voltage moves amperage to beat resistance, and we're talking about a derivative of Ohm's law. All right, for anyone that remembers that. We're going to keep it simple with this today. I'm now going to plug this in. How would this look on a locator kit? Turn the transmitter on. This rectangle up here in the corner has your battery inside of it. It also has your bars of output. When we're talking about output, now we're talking about wattage. In this case, this is a 10-watt transmitter. The first bar is 10%, second bar is 20%, third bar is 50%, and finally the fourth bar, kind of sort of all 10 watts. If I held down the up arrow, it's going to go from 7 all the way up to 10. Out of the front of here, I have an A and a V and a target line. Where else have I seen that? A and the V and the resistance. That's letting us know that we have leads plugged in. If I plugged in a ring clamp, it'd look like a ring clamp instead. Up here, I also have my speaker volume. This is a Bluetooth model, so this can be remotely paired to a receiver, and I can change output level and frequency from up to half mile away without walking back or driving back to my locator kit. So if you have longer distance locates, there's things like that that can help you out here too. I'm in 8 kilohertz, which is my frequency, and right now, I'm going to show 0 milliamps, and I'm going to go all the way up to 30 volts. That's with the leads not touching one another. If I take the leads and put them together, now nobody fall out of your chair. I had one poor fella at an electric co-op of all things. As soon as I did this, he said, "Did you just destroy that equipment?" No, you know it's making a return path. It's using the earth to get there. So this is quite all right to do. And if you ever feel like your leads are going bad, you want to double check them, put your leads together, see if you make a circuit. And right now, I know it's hard for you all to see, I showed 20 milliamps and no volts. Perfect circuit, no resistance. So what am I up here talking about? In the first instance, 0 milliamps, and I had 30 volts. Then, put the leads together, 20 milliamps, no volts. So if I measure the movement of current out here on my circuit in amperage, in that first case, did I have any movement? Did I have any flow? No. And what was my resistance? That air gap between the leads. And it couldn't overcome that. So what is my machine doing for me when I'm at 30 volts? Trying to push this through. So it's pushing with everything it's got. It's maxed out at 30. Now, take the resistance away, put the leads together, 20 milliamps and no volts. So our goal, for the most part, is going to be, we want to hit our high milliamp potential, and we want our voltage as low as possible. When I say high milliamp potential, what I'm talking about is this. I'm at 8 kilohertz as the frequency, and I was at 2 bars of output. If I change those factors, this number can be 5, 10, 20, 50, 100, or 500. But in this case, it's going to be 20, so I can't get more than that. But I don't want to settle for less than that. I want to hit my high milliamp potential, and then I deal with my voltage. And that voltage can be anywhere between 0 and 30. So, right now, we have a really good circuit. We have no resistance. 20 milliamps, no volts, perfect circuit. Everything's good. All right? How many of you do tracer wire locates? Yeah? How many of you have instances where you wish you had tracer wire to locate? How many of you are out there right now replacing steel and fixing stuff with PVC and not putting in a tracer wire to jump it across? You liars. I thought we were in a different place. So, whether you do tracer wire locates or not, this is an example I give to everybody. This will really bring locating to life. Here we go. This is an example, comes to you by way of Topeka. I live on the Kansas side. I'm from the Kansas City area, and I graduated from KU, so Rock Chalk Jayhawk. Yeah. Nobody threw a shoe, nobody threw hot garbage. I appreciate that. Thank you, thank you. Other parts of the state aren't as kind to me. That's all right. So, I went out there and I'm doing a demo with a fella. He's already got our radio detection stuff. He says, "Hey man, would you come and look at one of my locates with me?" And I said, "Yeah, sure, no problem. What do you like to do?" What we did in this case was we went to a hand hole downtown, opened it up, and he's got 3 fiber optic cables inside, all inside of interduct, all with tracer wire in them. So he has 3 things to mark, but how many things does he have marked? 4. Do we already have a problem? Yes. Then he turns his equipment on. What does he have? 1 milliamp, 29.9 volts. based upon what you've learned today. Good circuit or bad? Bad. So I asked him right then, I said, hey, do you know what these numbers mean? Do you know what this is communicating? He says, nope, not at all, never look at them. Kind of proud of it, right? I said, okay, well, now the reason for that is, since we had sold them the stuff, he's been hired, and he never had any real good locator training. All the information he got about his locator and locating he got from his boss. Anybody ever get bad information from a boss? All right. A couple weeks ago, I had a guy in the back row, and he dropped his head. He said, every day. I was like, every day? He's like, every day. All right. So I explained to him, if I could just do it with you, what these numbers mean. He said, okay, I think I get it. 2 blocks away, in my next handhole, my trace wire just comes up out of that duct and hangs there in the air. In the bottom of the box, he's got a ground rod. He asked me, and I'm asking you, he said, should that be bonded to that? Should that be grounded on that end? Who thinks the answer is no? Who thinks the answer is yes? Yeses have it. So he runs down there, pulls his tracer wire over, he takes some vice grips and just pinches it off real quick, rounds that out, comes back to me, 50 milliamps, 2.8 volts. Good circuit or bad? Good. Good. And to prove the point to him that day and you all today, I then took it off his little ground rod, put on my probe rod, 0.8 volts. More earth contact, lower voltage, lower voltage. Again, all this is being supplied by the batteries within your transmitter. Okay? So, if you want to save some battery life, ground yourself out better, and that'll be a good byproduct. So, he's finally ready to do a 360 sweep again. He does a 360 sweep of his handhole. And what do we find? There's his fiber. He was 6 feet off on this side, and he was 4 feet off on that side. Not close enough, right? How did he get 4 things marked with what you correctly identified as a bad circuit and still missed what he was after? How do you do that? He bled off. Okay, you're exactly right. And in this case, I'll go ahead and tell you, what did he bleed off onto? Well, this was the water main, and that was your traffic signals. But he did something. He did something that most locators have a problem with, especially when they're new and learning all this stuff. What did he do to make the bleed off happen?
Cranked her up.
Cranked it up. Yep, you in the front and Cowboy in the back. You both got it. He cranks it up. So what that means in our terms is he went to higher wattage, higher output. Let's leave the gain a little bit higher. Let's just crank it up. But when we do that, does that lead to good results? Well, it can sometimes, but for the most part, what you're doing is you're adding aggression and agitation to your circuit. The calmer and smoother you can make it and keep it, the better off you are. So when you jack everything up, just to do it, you're inviting bleed off. So these are conductive, and his current didn't have a reason to travel out here before, because it's not grounded. Now he's given it one, and now he has a return path, and this becomes very simple. And his eyes got big and his butt puckered, and he said, oh my goodness, I have to redo everything in the last month and a half. I've got to go. How often does your wire just come up and sit there next to a hydrant or inside of a valve, or comes up and makes a U and you strip back a little bit of it? It just sits there. That ground is what draws your current down to that end and then helps complete your circuit. I get people argue with me all the time like, hey, I can get that to run without having to do all that. I don't need to be grounded on that end. You can get away with it, yes. But on the wrong day when you have enough congestion, again, I know we keep making light of it, but all that fiber going in the ground, more and more opportunities for bleed off and things like that. So the lower you can keep your wattage, your voltage, your frequency and everything, the better off you can be. We'll talk about frequency selection here in a little bit. So let's go with this. What if I had sent him down there and he found that was already grounded, but he's still reading like this on a tracer wire? Yes, he's got a break in between. Who said that? Good. His wire's broken. Somewhere out there in the middle, because if you think about it, if you had your way, especially like on a tracer wire, would you set up your transmitter here? And if you had infinitely long leads that went in each direction, would you run those out to each end of that tracer wire and get on it and just make a loop? Yeah, he's done it. Absolutely. And if you had a break, where's that break have to be? You know your leads are good. It's got to be out here, right? That's fantastic. So what we're communicating now is with these numbers, this is giving us a profile of what is or is not happening out there on the circuit before we ever grab that darn receiver. Everyone's in a hurry to grab the receiver because the magic box is making magic noise and I'm going to go locate it. So understanding what's going on with our locates and our site and also what's being communicated to us right there in front is very, very important. Right? This is the ball game, and it's about your transmitter. For me, that's what I always say. It's about your transmitter way more than it is your receiver. It gets ignored all the time. All right. We'll finish covering your transmitter. So when I turn this on now with nothing plugged in, I have
Sorry.
no, you're fine. 3 waves coming out of the bottom of the box. Right now I'm in induction mode. How many of you have ever induced or done drop box method or had the old Fisher split boxes and things like that? All the same kind of thing going on there. So when I turn this on right now, in this frequency, I am pushing out current to be able to induce and light up a line using this gigantic antenna. All right, you can do that for a couple different reasons. You've got something really, really stubborn like cast or ductile iron. It's great to go out there to induce, set this down on top of a valve and light that up. The way that most folks have issues with this is they stay too close to their transmitter. You want to get 30, 35 feet from that thing. All right, if you stay too close, you're inside a giant dome of current that's putting out and you're still locating the box. We call that air coupling. So you gotta get far enough out and away that you can pick up the current that's on your facility. All right, and also because you're dealing with something stubborn, your direct connect is your preferred method of locating with the red and black leads. By the time we're getting to this, we're usually in a higher frequency, something like 65 or 80, 82, trying to get current to move on something that otherwise doesn't want it there. So you do have that at your disposal. How many of you use ring clamps when it comes to locating? Got some ring clamp users? All right. So ring clamps or induction rings are great, great tools. Now, the mistake a lot of folks make with this is they think that this is closer related to these, and it isn't. They can see what they're applying this to. They can see what they're applying that to. They think it's the same. This is actually more closely related to setting your box on the ground than it is the red and black leads. All that's happening inside this ring is current is being forced to move to the point that you induce an electromagnetic field to appear on whatever's traveling through it. So a lot of current going out in different places, and very little of your current with respect to this actually makes it on the line when you're using one of these. The way this gets most folks in trouble is usually electric locators. They get in the habit of just throwing this around their electric line. Any electric locators in here? All right. The problem becomes, and I think electric locating is maybe the most difficult locating that you can deal with out here because you have to stay grounded. So everyone else that's also grounded, you want to get them off of the top of you because they're all going to start to bleed off. Your current's going to treat it like one circuit. That becomes an important principle. When it comes to this, still a great tool. Use it for things, dipping and rising up, down poles, things in handholds, things in manholes, stuff like that. The best application for this, for your safety, since we're all at the safety summit, is you have an open trench. And someone's found some kind of conduit or a fiber or something like that, and it's in there along the trench wall. Instead of getting down in the hole and risking a collapse, get your hot stick out, stick this down in there, articulate the fingers, get around it, and not have to get down in the hole at all. Too many people die in trench collapses and things each year, and it just needs to stop. So stuff like that can help you a lot. Your best inductance within this ring is right here at the apex. So if you have something, a lot of times you're dealing with 2-inch and 3-inch, and it kind of fills the whole void you see there. But if you have something really small, like a drop or a small fiber or something, you want to position it somewhere, you would try to cajole it and position it there. All right? That is a 4-inch version. There's also 5-inch. There are also some that are flexi couplers that are 8 and 9 and things like that. So you want to get something when you're buying that's appropriate for whatever you're applying it to. So if you have 4-inch 3 phases and things like that induct, it'd be nice to have a 5-inch as opposed to a 4, and just kind of buy what based upon what your needs are. But yes, but he's also exactly correct. Questions on any of that? All right. So let's talk about frequencies. Somebody shout out their favorite frequency.
512. 33.
I love it. Oh, we got a 33 guy. Anybody a 65? When it comes to frequency selection, what we prefer, and again, these are not absolutes. I'm never the guy that tells you that there's one frequency you can use or don't use those, whatever. To me, they are tools in a toolbox. You have different times to apply each one of them. That's all right. especially for those of you that locate multiple types of facilities. You have water and gas and street lights, traffic signals, things like that. There's different times to employ all of this. Now, the reason that we like low frequencies is lower frequencies have these great, big, long, mellow waves. Less chance for bleed off. The higher we go, on this end, little bitty short waves, lots of opportunity for bleed off, a lot of agitation, a lot of aggression. And also, which one of these traveled further?
Small.
Right. Now, on this end, they burn up their energy in a short amount of time. You just don't get as much travel distance. You may be wondering as I'm doing this, so these two numbers seem to be larger than those. Why would these be low to high? These on this end are in hertz. So when I said earlier that your transmitter is a giant switch alternating current at the frequency you're asking it to, it's literally doing that 256 times a second, 512 times a second. And then once we cross the 1,000 barrier, we start to get into kilohertz. Now we're at 8,000. Who's my 33 guy?
Sitting right here.
33,000, 65. And it's mind-boggling, but it's true, but we get up to 200,000 times per second. So when choosing a frequency, it's not just choose one to choose one. All right, they're doing different things, and we want to treat them as such. These are like golf clubs in a golf bag. Would you grab a putter when you need a driver or vice versa? No, there's different times we want to use these things. Now you will find, I heard a lot of people saying 8K, about the most universally loved frequency out here is going to be this 8K range. There's a 9.8 and things like that, but right around there is kind of a sweet spot for most people with most utilities. But if I have things like tracer wire, I could probably get away with 512. As I move up and I've got steel, probably be an 8, sometimes 33. Cast and ductile iron, 33, maybe up to 65. And then I get into where I'm doing the drop box and doing induction. I'm probably going to live up in this range for the most part. So different opportunities and different reasons to use different things. How many of you do traffic signal locates? Anyone? Okay, a couple folks. So go back to our grounding and all this situation. When you've got a traffic signal loop and you've got those masts at each corner and you've got a horseshoe, what ends up being the issue for these guys? Everything is grounded at that controller box. And when their wires leave, they run out to these different masts. Did someone say milliamps? When they run out to these different masts, are the wires actually grounded there? Do the wires even get exposed? No. They go out to the mast, they run up the mast, they go inside, they go up and they feed the lights. So does your current want to go out there like we had in the Topeka example? No. So where do they usually end up? I usually have luck around 65 because now I'm so aggressive that I can get current to move out to these ends because higher frequencies aren't as smart as low frequencies. So low frequencies know, well, all my ground is back here. I'm not going anywhere. I'm going to stay there. Higher frequencies start to race around and investigate everything to the point that by the time they realize there's no ground there, they've already traveled out there and now you have the opportunity to locate it. So again, different tricks in the bag based upon different frequencies and their properties, and you're using their properties to the best of your ability. Your goal, though, is to use the lowest frequency that also allows you to get your locate done. And that can be any of them. The word of caution I like to give everyone right now with all this different fiber stuff going in the ground. So if you're out there on the easement and you're doing a locate, and you like something like 8K, and you pull up someone's already locating, what are they likely to maybe be in? 8K. So you do have a couple of different options. One, you can change frequencies, and we'll talk about that. Number two, you can wait for them to get done. They like 8, you like 8, do that. Some of these models, we can actually do a side step, so you can go like 8.1 or 8.2 and stay right next to 8, but not foul each other up. So you have that as an option. But I find a lot of folks out here, when they're going from frequency to frequency, what do they almost always do? When someone else is using 8, where do they go? Up to 33. And some of your kids out here have a plethora of frequencies like 4K and things like that. You can go down. You don't have to go up, but everybody likes to go up. So if you could get it to work lower, that would actually be your preference. You're not choosing one just to choose one. And as more and more folks are out here, they're going to have reasons to ask them and communicate and figure out what they're running in. So more folks with more locator kits doing more things and busier, more congested easements, it's going to be important to understand the principles of locating and why I would choose a frequency over another, or what I want to do, and have a plan when I show up there if someone's already on the easement locating. All right? Don't lead yourself to damages by accepting a bunch of risk that the other fellow simply doesn't have to because you're being the nice guy. All right? Everybody with me? Yes.
Well, the reason I like 33, and you might be able to help me with this, but like on short side, I can hook up to a short side gas service, but then I can pick up long siders on the long side of the street on the 33.
Right.
So then I don't have to hook up to every one of them. I'm picking them up, so then that just saves me time. It seems like it does, because on 8, it doesn't seem like I can pick up the long sides on a short side service.
Right,
So I'm
right.
just trying to save me some time from having to hook up to each service. And 33 seems like it helps me. I can pick up the long sides on just one service.
You're exactly right. And the reason he's right about that is, if I were an 8 and it comes out here to my main and it's got good ground, it's going to go there and that's going to be all it can get. But again, you're going up to 33, so it's going to investigate more things before it returns back to that ground. And if I had time to draw it, which I'm going to do right now, if I drew a distribution system though, all right, so we started with 20 milliamps. And if I've got 20 milliamps in my transmitter traveling down that service, and I'm in a good low frequency like 512, I probably have close to 20 making it all the way to the main, right? So I might be at 18, 19, something like that. But once I get to the main, it should split, and it's going to go one way or the other. All right, everybody tracking with me? So let's say I got 20, 1 milliamp goes this way and 19 goes that way. Where am I going to get my better locate? That way. And why is that? Well, maybe this is all plastic and I'm on a tracer wire, but I've got a steel main a block and a half away. It's drawing on my current that way and treating that like a ground rod. So now I get the question all the time, so what should I do to get it to want to go this way? Well, you either move your transmitter further upstream so you can go that way, or go out there and ground everything, or potentially be in a higher frequency. And we even have some slides that get into this too on one of our other presentations. The thing that's misleading about it is when I show you a slide that just shows, okay, here's what you were doing in 512, 8, 33, 65. And as we go, it looks like we get a whole lot more of our locate done, because the higher we go, the more it travels out on everything. But what it doesn't tell you is all the other layers you have: street lights, traffic signals, gas, water, power, it's just on and on and on, to where you have all these opportunities for loss. The other thing you'll notice is when we were in 512, we got 20 to come out to the main. But as I go up to 8, maybe I still got 20, but I get into 33, now instead of 20 making it to the main, I have 16. Guarantee you're losing milliamps that are getting out to that point. They're escaping into the earth before you ever get there. And the higher you go, the more of that starts to happen too. And now you're into more chances for bleed off. So you got to find that balancing act. That's what's funny about frequencies is everything is about finding an actual balance. It's not living with one or the other, but you're having success, so you're fine. Again, I'm not the guy that outlaws or overrules anything, but that's why you're having
My
that
town's
happen.
small enough. Most of the stuff's aerial. I mean, your normal water, sewer's in the ground, but phone, most of the time, power's all aerial, so the bleed off is kind of minimum,
Yeah.
it seems like.
Yeah.
So it works for me there.
Well, that's good. But again, as you move on through time and more things go into the easement, more fiber gets installed and stuff like
Well, we have
that.
fiber in town now, so USIC's usually on 8. So they're working the same street I am, because
Yeah.
they're going through Richmond right now running fiber, so
Yeah.
we're having to deal with that.
Good luck to you.
Yeah, I know.
All right, questions on any of this? So when it comes to your receivers, you all have something similar to this. All right, and this looks hardy, and it is to a certain extent, but the first thing I want to talk about is when it comes to this is a high weather resistance rating, but it's non-submergible. All right, so a lot of your stuff will short out if you're out in enough rain and things like that. Something to help my guys years ago was if they had to locate in the rain, they put turkey bags up over the top of this and put a zip tie or something on there and just keep the display nice and dry. So you guys can try that. And the same thing where your transmitter fits nicely inside of a turkey bag as well. So if you want to keep moisture and things off there, dust, dirt, and moisture are the second, third, and fourth enemies of your locator. What's number 1?
Abuse.
Dropping it. Abuse. That's right. Don't kick it, drop it, throw it, get mad at it for the way locate's going. It's not its fault. Whose fault is it? Your trainer. All right. So you can get your train. All right. But what you don't want to ever have happen with your receivers, you don't want anything rattling around. If it sounds like a rain stick, things like that, that's bad. Because what's inside of here, this is our antenna array. And you all have something similar no matter what you're using. So you have two peak antennas, which are horizontal, 2 vertical null antennas. You have an air core antenna that populates your compass. And they're all affixed to this board that you see here, and then we've got a motherboard up top. So if things are rattling around, it can really only be parts of either your board or parts of your antennas or something like that. All right? So try not to abuse them if you can. As we move on into the display, I'm going to start by showing you your electromagnetic fields again. So this is our target line. That's our facility. And off of that, every time I draw this, I can think of one thing. So remember when your music teacher would like draw like 4 lines across the chalkboard? Most of you remember chalkboards, right? I'm not like that far into it. Okay. And then they could do like the scale and things like that and notes and everything. That's what it makes you think of. All right. So you have electromagnetic fields radiating out off of your facility, and they're in constant motion. So they're oscillating and swirling and moving all around. When I turn on my receiver here, I have a display. I have my gain meter, which is going to be up at the top. I have my battery, and then I have decibels. So right now I'm at 120 because I'm in radio mode. When I'm dealing with my active locate frequencies, 140 is going to become a very important number to us. Then I have directional arrows. I have my high percentage. This compass is giving me the orientation of the line that I'm following. That's why it exists. There's my frequency. Now frequency will turn into milliamps when I'm directly over the top of the line. So I don't have to press anything to get that, and I will automatically get my depth over here on this side too. So milliamps of depth are going to be provided to me constantly when I'm over the top of my facility. Now we're going to get into your antenna modes. So the first mode we're going to look at is going to be peak. So when we're looking at peak, we're talking about a response that's coming out of just these 2 horizontal antennas. It's going to operate something like this. No sound, sound over the top of the line, and then no sound again. There's your hill. But if I hit the mode button right here, I'm going to get a peak and a valley over the top of each other, or as my boss refers to it, the 4-legged spider that you see right there. All right. So what I've just done is I have turned on my 2 null antennas, which are the verticals. You used to use null all by itself, and it's still available in a lot of this equipment, but people are moving away from it because it leads to a lot of damages, especially in bends and curves and 90s and things like that. So we used to use it back when I first started to verify peak, which you can still do, but it's not the end-all be-all. Now we use it to populate arrows that tell us left and right when we're in a thing like peak plus. And it used to be constant sound, no sound over line, and then constant sound again. Now we're using this to drive arrows. So what am I talking about? If this were my target line, I've turned on my transmitter, everything's moving. It starts off on the larger end of the cone, closer to the transmitter side, and then it tapers off to a point. So I set up out and away, and I get ready to sweep in toward my current and toward my line. So I get about 10, 15 feet away. You don't start your sweeps on top of your line, on top of your leads, your ground, anything like that. Get away from all that. It has electromagnetic fields popping off it. We want to walk into our current. So we set up, and we start to go. Once we enter the null field, we will start to read data from the top or the bottom of the antennas based upon which side we're on. And as we do that, now our equipment knows which direction to send us. So on this side, arrow sends us over. On that side, arrow sends us back. These vertical antennas are blind to whatever they're above and cannot see down. So the reason that we know we're close to top dead center when our arrows disagree is these can't see anything. Now your peak antennas take over and they bend and pull with these iron ferrite rods to pull as much information through the actual antennas as they can. They take independent readings and then they correlate together. And that gives you your accuracy with depth and everything else. In fact, you won't get your milliamps in your depth until you're just about to that point. But we don't use arrows to locate. We stick to the percentage in the middle. All right? So that's our peak response. So we'll start at 140. We're going to hit a plateau, 99%. Well, I can't get on top of that and I can't see above it. But I didn't accidentally walk over my current. So when I find that, and I find where the arrows disagree, now I can hit the down arrow, drop my decibels from 140, maybe down to like 45. And now I'm going to have something around 27, 28, 36, all hypothetical numbers. But now I can find the peak because as I sweep across, I will cycle down to 0 on each side. And I'm looking for that high percentage in the middle. That is where I commit my time, either to dig or to paint or flag or whatever I've got to do. That's what I'm looking for, not arrows. In fact, as you go further back in time on some of the older locators, those arrows could be further and further off, 6 inches, a foot, something like that. But your peak response should end up in the same place. So that is where we like to live. We have other options when it comes to the locator as far as antenna modes. There's null, so that's our valley again. And then we also have this, it's called single mode or broadband, depending upon where you're at. So with this one, how many of you have to locate underneath of overhead or high tension power lines and get distortion and stuff off that ever? All right, so that is what this is specifically designed for. When you're out there doing a locate, you have those overhead power lines, they are automatically generating their own electromagnetic fields. Those are coming out at you from above. So these two antennas are starting to read that. Then you've created your own underground with your transmitter. So now these are trying to lock on there. And we're going in different directions. And we have a fit. When we go to this mode, which looks like a little eyebrow, we're turning the two upper antennas off, going with these two, and submerging them into the electromagnetic fields that we want it to focus on and get away from the whole correlation situation. All right, so that can help you with that and give you a proper depth and everything else when it comes to this. And last but not least, how many of you are old Metrotech or Dynatel users and all that? All right, okay. So this is called guidance mode, and this is meant to mirror exactly this. So meter's always full, it's automatic gain, so we do no more up and down with the arrows. This white bar is going to try to line us up directly on top of our facility. In fact, when we're away from it, white bar is going to be that side. When we cross it, white bar moves to the center or goes this way. So when you're on top of that and it gets quiet, you know that you're top dead center again. You still get milliamps, you still get depth, you still get your high number, even though it's not a percentage, it's a 3-digit number. And then you're going to hear that old fabled dut, 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 right? Okay. So where did that come from? Some of you have taken my class have probably heard this before. So bomber planes in World War II, depending upon which side you're on, they're all using guidance systems. That guidance system, why we call this guidance mode, is you veered off path, your cockpit went dut, 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 left, 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 left. Go the other way, right. So this sound, I know I can't sing, don't laugh like that, right? I have many talents, that is not one of them. Now, but those sounds are actually telling you directions to go to find where you're trying to be, and the null and where it's quiet in the middle is where you're going to commit your time in that case to paint, flag, or dig, or whatever you got to do. And that's how you locate with this. Let's jump into next. How many of you have ever used any of the passive frequencies you have, like power mode? All right, so what power mode is good for is this is independent of the transmitter, so this is completely passive. So power mode is designed to find the electromagnetic fields that power is already creating at the 60 hertz cycle, and will give you a depth down to it. If you haven't seen this before on the newer models, when I hit the mode button, I have 60, 180, 300, 420, and 540. So those are different degrees or phases of power in the harmonics that they're putting out. So if you have a congested area with single phase, 2-phase, and 3-phase all running in there, when you sweep at normal power mode, you're going to get like a 40-foot wide swath of red diamonds. Anybody ever seen that? Encountered that? Absolutely. With this, you can sweep in the 5 different degrees and pick up 1, 2, 3 ducts, and no more specifically, I'm trying to cross it here, there, and there and get depths down to those. So you have 5 power filters instead of just the 1. All right? Next, this one's kind of a mystery to a lot of folks. Radio mode. Anybody ever use radio mode or seen a little cell tower icon on your locator? So what radio mode is designed to do is to find static electric buildup. So how does static happen? Well, the cell tower sends out radio waves. Those radio waves permeate the ground. They move on anything conductive underneath. That movement creates friction. That friction creates static, and this finds static. Now you don't get a depth in this mode, so it's unlike power mode in that respect because there's no electromagnetic field to measure to the center of. But it can give you an idea that something is there. Because you have static, you have movement. And because you have movement, you have something to avoid for safety purposes or liability purposes. All right? So how this work for you as an excavator? You've got your job site. You come out, grab your receiver, sweep in power mode, double check the power. Someone else that marked it for you, come back to in radio mode. Now, I got a bunch of static on this fiber. I find the power again, but things like conductive water mains, all that movement of water and all that flow, tons of static, it loves water mains. conductive gas, especially in the winter time when there's more gas is being used, lots and lots of static, you can pick that up too. So as an excavator, this one can be a real lifesaver. Everyone goes towards power mode, which that's great because you don't want to get into electricity, but radio mode can find a lot more things than even power mode does. And if you get something out here where no one's got anything marked, maybe a locator had a bad day. Anybody seen a locator have a bad day? Okay, that was a no. That was a solid no. They all do all right all the time. So, or maybe we were the locator and we've had a bad day. Now, maybe they mismarked something over here, or they missed something altogether, or is there something private passing by that no one's going to mark for you? The radio signature can give you an idea there's something there that you want to avoid before you ever pierce the ground. All right, so that can be a real lifesaver, and that's a good one. That can be applied to plastic with no tracer wire, but you got to have a ton of flow because there's nothing really conductive. A coworker of mine said he's gotten into work maybe 2 times ever, but that was with hydrants open on both ends. Now, something it can help with, how many of you still have AC mains out here? We got AC mains to deal with, okay? So the asbestos can hold the static buildup within that too, and so that is the mode in here that can help you with that as well, even though a lot of folks think those aren't conductive. But again, if I can generate more flow by opening up a hydrant and create more static, I'm gonna have a better chance of that. All right? Next, turn this back on. I'm gonna go up to CPS mode. CPS mode is for cathodic protection systems. This is meant for rectified lines. How many of you mark gas and how many of you have rectified facilities? Okay. So within that, and for those of you that work around those areas, this can also help you as well. So a rectifier, for lack of a better term, is a power box. Puts out 120 hertz onto your pipeline, changes the polarity of the pipeline to match the earth. You match the earth, you don't get corrosion. So 120 hertz is our frequency. So the rectifier is already doing the job of a transmitter. We can go out and pick that up with our receiver and get a depth down to it. So for those of you that have rectified systems, that can pick it up without even hooking on with your transmitter if you so choose. Or if you have cross-country transmission mains, things like that, they've all got rectifiers on them. You can use this on this as well. A lot of the folks in the pipeline industry love this kit for this very reason. For those, what's that?
What was the?
CPS. And in your kit, it may be turned off. You have to go into the menu, but it's going to say CPS there in the corner. And it's always going to be right after radio mode. So you can go power mode, radio mode, and you'll find CPS, unless passive's turned on, things like that. But I can help you with that. So, yeah, that's a friend to you. For those of you that aren't locating the gas, when you're out there as an excavator now, all right, you already swept one time in power mode. You swept again in radio mode. Now you can come back through in CPS mode. If it's rectified, you have to talk to your local gas operators. Yeah, there's that main, there's a depth down to it, and without even touching it or being invasive in any kind of way, you can get a better profile of what's going on with all these facilities before you ever stick a bucket in the ground or anything like that. So it can be real life-saving stuff. How many of you, I say questions, what questions do you have? And I've got something I might draw for you. How many of you have tracer wire that goes out to the end of a dead-end main? And it's just buried there. All right? Okay. Let's dive into that because this sheds a lot of light on a lot of things too, and I can get through this before we're out of time. So you've got a dead-end main. It's plastic. Could be water, could be gas, makes no difference to us. You set up down here and you've got your transmitter. Okay? Let's say I'm running in a good frequency, something like 8. Very mellow. Get out of here. Mark that as my dead end, and I was running in 8K. Did I make it to the end of my dead end? Remember, all that's out there is buried in a tracer wire. So why didn't I make it all that way? It's not grounded. Exactly right. So 8K gets out to here. And not just with a buried tracer wire with nothing grounded on the other end. Think about things like Jameson tools or a fish tape or any kind of rodder that you've got and things like that. It's all the same situation. You know you're not grounded on the opposite end. So 8K gets us there. So now, rather than go down, we go up in frequency. A lot to do with locating. We will give you the opposite principle depending upon your situation. And this is one of those. So now I go to 33 and I get a little bit further. Remember we were talking about 33 being more exploratory? That's exactly right. So 33 gets us there. We go up again. 65 gets us here. And finally, I end up at something like 82 or 83. And I finally reach this. That is typically the frequency I end up with when I'm dealing with like Kansas Gas and they're running a Jameson tool down into a live gas service. Just to go from the meter on the side of the house out to the main in front, we typically end up around 83 or 82. So again, we're just using the aggression levels of each of these to go further down that trace wire that's not grounded on that opposite end so we can locate it. Do we want to start at 82 and just forego all this in the middle? No, we want to use these as control points as we systematically move down the line to know if we're bleeding off. Because remember, we have other facilities in and around this out there on the easement.
You know you're at the end at 82.
Okay, great question. I'm glad you asked. So let's say hypothetically, back here to the transmitter, I have 20 milliamps. So let's say for sake of argument, we got here and I'm showing 18. Let's say I lost 1 milliamp up this service, 1 milliamp up this service, and I'm just at 18 here. So I've got 18, 18, 18, and 18 for the sake of argument. And I'm running it a good 3 feet deep. When I pass that end, I will then find residual current that's bleeding off into the ground on the opposite end of there, and I'll start to pick that up. But my numbers on my display will show something like 27 feet deep and 0.35 milliamps. And I go, whoa, what just happened? Well, that nosedive and this low amperage lets me know, all right, I'm into what we call the bubble zone or the ghost tone on the back end, things like that. So if I go even further, as I walk, I'll eventually get 0 and I'll just blank out and I don't read anything. So now what I do is I work back to the last point that these numbers were consistent with where I came from. It gives me an idea that I'm very close to that end there. Now, if you're locating gas and you've got measurements, you want to be able to double check that and everything with measurements, please do so. I'm sure that's policy most of the places that you work at. But this is how we would get closer to that rather than I followed all the training, I stayed in a low frequency, I did everything right, I ended up here, and what happens? Excavator comes behind me and I get smoked on the back end. How many of you have seen that damage or had it happen to you? Or, yep, happens all the time. Everyone says, well, I stuck to my training. What we would implore you to do is, instead of just burying the end of a tracer wire out there, put something like an anode spike or put some kind of an access point. Access points are even better, especially if you're a locator. The more access points I have, the happier I am. Something that comes up to the surface, or at least an anode spike, something that's going to draw my current out there and I know it wants to go and find that. It loves anodes. So now my current will go out there, I can locate it very easily, I can stay in a low frequency the whole time and not have an issue. But we need to think about those kinds of things as we install and repair facilities out here in the ground. What's going to maintain locatability or give me the best bet so I can locate it in the future? And that gets overlooked by lots and lots of folks. Like the guy in Topeka, why are we not already bonded and grounded on each end? Should be. So every time we go there, we should unbond within the handhole, hook up. We know we're grounded on the opposite end. We get done, we rebond. Now we go to the other end, 3 days, 3 weeks, 3 months from now. We know our current will go back this way because we're grounded on that side. I had guys for years on my locate teams, they'd unbond in an AT&T ped on this side and say, well, I'm not going to mess with all those nuts and bolts and stuff, and I'll just be faster next time I'm in this ped if I leave all that stuff off. Do they ever get back in that ped again next? No. They end up 3 blocks away down here. They get in the next ped, they unbond everything. Does my signal want to travel now to that one? Nope. They've left it open. And what do they all assume? Oh, the prints must have been wrong, and they just don't locate it. No, you left it open on the other end. Now it's not grounded. Your current doesn't want to go that way. It goes the other way because there's better ground that way. Very simple. So for those of you that don't believe in rebonding and putting your bonds back at the end, you're hurting yourself down the road. The other thing that's possible with that is, just help you water, folks, before we get out of here. So say you got your trace wire that comes up. I see this a lot. Comes up into a valve. You've got some 4-inch PVC, something like that. Just comes up, makes a loop. You got your blue tracer wire. Someone cuts off a little bit of the sheath, and then you hook directly to that part, right? So what happens if I go and I get on that, and I'm from this way, I'm not grounded on that end, but I'm grounded this way. It's going to run that way. And I see a lot of folks that will leave all those loops together. I encourage people, I like to cut them. If I cut that there, now I've isolated that leg. Now I can rebond it so that when I hook up 3 blocks from here, I can go past this point. But I want to be able to isolate that. Now I can hook on, if I get a tone this way, that's that one. When I go on this wire, if I don't get anything, I know this is my wire that's traveling that way. I need to figure out either how I'm going to ground it or what I'm gonna do to try to get it to travel down that way, instead of leave all those things together. That's my preference when trying to locate, because I wanna know, I don't just want my current being stolen, because I know it's gonna be. Because if that ties onto a steel main that way, and it's all plastic this way, off it goes. All right, anybody that'd like to talk to us, at the end, you've all been a great, great audience. I appreciate being here. I know this room is hot. Thank you for suffering through with us and everything. We appreciate everyone, and if you want to talk to us at our booth later about any of these concepts or anything else, we'd be happy to do so. Thank you all for being here. Have a great, great conference. Thank you.